everybody, and welcome to this third clip of the organic AQA chemistry section. And so what we've been looking at in the previous few clips is crude oil and what is starting to understand is the makeup of crude oil. And so we've worked out that crude oil is essentially starting life as a thick black gloopy mixture, so a very sticky, heavy liquid, but essentially is fairly useless. It doesn't really have any direct uses. We have to purify it. We've got to separate it into the individual components which are in there, which are much more useful than the parent mixture is. And so how we do that is via the process of fractional distillation. And so fractional distillation operates in the following way. So what we do is we pipe the crude oil into a large metal tube. So this is a very large vertical metal tube which has a series of pipes coming off the side of it, and they'll become important in a second. And what we do is we essentially put the crude oil into the fractional distillation column, which is what this thing is called. And importantly, what it's important to appreciate is that it is hot down at the bottom of this column, and importantly it is cold. It's not specifically cold. I mean, it might still be 40, 50, 60 degrees, obviously depending on the temperatures that are being used, but if we say, just for argument's sake, that it's 50 degrees Celsius at the top and we say it's 350 degrees down the bottom here, then we can appreciate that it is simply cooler at the top and hotter down at the bottom. So what's going to happen is the crude oil is going to go into this fractional distillation column, and in the first stage of the process it's going to be heated up. Okay, so in the first step the crude oil is going to be heated. So if the crude oil is starting life as a liquid, okay, so we've got a state symbol L there indicating a liquid, then the crude oil is going to go into here and it's going to be heated. This is going to cause it to evaporate. Okay, so it's going to evaporate. This is going to turn it into a gas. Okay, so as we turn this into a gas, the crude oil is going to start to rise. So if we make the assumption that hot gases will rise, the crude oil now as a gas is going to rise up this column. And so it's going to continue in a vertical direction up the column. Now, as the column has a temperature gradient in it, because as we've said at the beginning, it's hotter at the bottom than it is at the top, this gas is going to cool. So as the gas cools, it's going to want to, at a certain point, when it reaches its boiling point, it's going to want to try to condense again. And what's going to happen is, because crude oil is a mixture, it is going to be a mixture of compounds which are going to have different boiling points. And so anything which has got a high boiling point is going to condense, let's say, here, and it will then become a liquid where it will fall and will then run into, let's say, this pipe here. If a compound within the mixture has a boiling point at, let's guess a number at, say, 200 degrees, something between 50 and 350, then it would condense, it would then fall. I mean, you could argue it's even raining inside here, precipitation, but if we say that's going to fall at that condensation point, then this may come out of this pipe here, and so on and so forth. As we go up the tube, we would see different liquids coming out at each of the pipes which have condensation points now, or boiling points, which are now different to each other. So as we go up this column, the compound which comes out at the bottom is going to have a slightly different boiling point than the one which comes out slightly further up. Now, we can make up numbers for the purposes of the discussion here, but we could say that this would have a boiling point around 75 degrees, this would be 130, let's say 200, and let's say this one has boiled at just under that 350 mark at 320. Now, because we have a range of compounds, we're going to have this range of boiling points. Now, because this is an industrial process and it's quite crude in the way in which the temperature is controlled down to decimal points and things, it just won't be controlled. What we'll actually get is compounds coming off in the same pipe which maybe have a range of temperatures. So what we'll have is a range of temperatures giving us rise to maybe the collection of compounds that are coming off being a series of compounds with similar boiling points. And this is the key thing to this. Each of the collection of molecules which come off at, say, here, will have similar boiling points. This collection of compounds which comes off in each of these pipes is said to be called a fraction. And as we say, they will be joined together by having similar boiling points. That's why they've come off at each of the pipes as they go along. Now, what you could then have is liquids which never evaporated in the first place, and they may come out of the bottom pipe because these may be high boiling point liquids, so high BP liquids, so substances which had boiling points in excess of 350 because they never managed to boil in the first place of the fractional distillation column. And likewise, if we happen to have some substances which happen to be very low boiling point, they might just pipe themselves straight out up to the top. But what we can do here is allow our mixture to enter into the fractional distillation column. They get heated, they evaporate, they rise, and as they rise they will cool, allowing them to then condense. And as we say, as they then condense into that liquid, they will be separated into fractions with similar boiling points. And what we need to then look at is the types of molecules which will come off in each of the fractions, and whether or not there are then some trends which we'd expect to see in terms of the structure and the types of compounds and subsequently the physical properties that each of these fractions will have. And so we will look at that in the next one when we look at the size of molecules, and we'll look at also the flammability and viscosity of the fractions as well. But essentially, just a quick recap, what we've done is we've taken a crude oil mixture, which is fairly useless. We've tried to put that into a fractional distillation column to separate out fractions, which are hopefully going to be slightly more useful, and they are grouped together by their similar boiling points via, in the way we explained it here, this 5-step process of fractional distillation. So, as I say, I'll see you in the next one where we will look at the trends of the molecules given out and compare the fractions travelling down this column. So, thank you very much, and I'll see you in the next one.